Okay, we're going to look at this question. This question is a thermal properties question from 2008 paper 2 question section B, question 10B. Alright, so this question is actually a very interesting question. Let's read the question now. A beaker contains 100 grams of water at a temperature of 50 degrees. An ice cube is removed from a refrigerator and dropped in the water. The ice cube is initially at all solid at 0 degrees and has a mass of 3 grams. When the ice cube has melted, the water is stirred and has a temperature of 46 degrees. The specific heat capacity of water is 4.2 joules per gram per degree Celsius. In this question, ignore heat loss to the beaker and the surroundings. So before we carry on, let's just remember a few key information that has been given here. Number one, when the ice is dropped into the water, the eventual outcome is that both ice and water reach thermal equilibrium at 46 degrees. So you need to know, first of all, is what is happening. So what is happening is that there is a heat transfer between the water and the ice. So heat is lost by the water as you know the temperature decreases, while this heat that is lost by the water is gained by the ice cube. So this is actually a transfer of thermal energy without any energy loss. So one thing you need to know is that ultimately the water and the ice reach thermal equilibrium at 46 degrees. But as you know, ice cannot exist as ice at 46 degrees, it has to melt. So because of that, we know that for the energy gained by ice, there will be two stages. The first stage is energy gain for ice to melt, and the second stage is energy gain for melted ice to heat up. That means melted ice, in other words, is water. Alright, so let's read the question. So the first question is calculate the energy loss by the water as it cools from 50 to 60 degrees. So this is very straightforward. Energy loss by water is specific heat, so it's mc delta theta. So the mass of water is 100 multiplied by 4.6 multiplied by the change in temperature of 50 minus 46, which give you 1680 joules. Now for the second question, the melted ice water from the ice cube gains energy as it warms from 0 to 46 degrees. Calculate the thermal energy needed to rise in temperature. So do be careful, this is actually melted ice, so the ice has already melted and we are referring to this stage of the process, which is energy gained by melted ice to heat up. So the energy gained by melted ice is also mc delta theta, specific heat. So the m in this case is 3 grams multiplied by 4.2 multiplied by the change of temperature of 46 degrees, which gives you 579.6 joules. The third question is the one that is most interesting. Use the answers in 1 and 2 to determine the latent heat needed to melt the ice cube. Now for this question, there will be two misconceptions. Number one is many students don't understand that this is the structure of the energy transfer. So they did not realize that the latent heat they are referring to is actually the energy gain from ice to melt. The second problem students face is they do not understand what is latent heat in this case. They thought latent heat is the specific latent heat. So you need to understand the difference between latent heat and specific latent heat. The analogy of latent heat and specific latent heat is just like heat capacity and specific heat capacity. Heat capacity is C is equal to mc, right? The same thing for latent heat. Latent heat of fusion, big F, is equal to mLF. So you can see that exactly they have the same characteristic. But the difference between these two is that specific heat is only for 1 degrees change, right? So that's why specific heat cannot be used, heat capacity is only for 1 degrees change. So heat capacity cannot be used for more than 1 degrees change. But latent heat itself is already the total energy required. You do not need another formula for this. But specific latent heat is the total energy required per kg. So in other words, if they ask you what is the latent heat required, they are simply asking you what is the energy required to melt the ice. That's it. What's the heat energy required to melt the ice? So don't get confused by this word. This word is just not saying anything more than just asking you what's the energy required. So let's look at the answer again. So remember, the energy supplied by the water goes to both to the latent heat, which is the energy gained by the ice to melt, and the energy gained from melted ice to heat up. We have found this, we have found this. So to find this, we simply we just change the formula around. Alright, so the latent heat to melt ice will be equal to energy lost by water minus the energy gained by melted ice. So you get 1680 minus 579.6, which is 11004.4 joules. Alright, so it's just a minus. Then the last one, which is specific latent heat of fusion, very simple. The specific latent heat of fusion will simply be equal to MLF. So it's MLF is equal to 1100.4, which gives you 3 times LF, which will give you 367 joule per gram. So this question is not difficult if you understand the process and the concept. So that's all for this question. Thank you.